Hi guys, my name is Peter C. Dogwa Jr., a mathematics instructor at the University of Liberia and your math tutor. And in my today's video, I will be discussing differential equation. And under differential equation, I'll be looking at verifying differential equation, verifying that a particular differential equation or a particular solution, or given solution. I'm not talking about a particular solution as it relates to particular solutions on a differential equation. I mean, whenever you are given a solution and you will be asked to verify that that solution is actually the solution to that differential equation. So you can do that verification so easily. So I'm going to just show you how to do it. So I will use two methods, and one of the methods is much easier to work with than the other. So let's get started. So the first method I'm going to use it's I'm going to work with, so I call it the derivative method. So I want to work with this solution because if you are given a particular relation, right, or you are giving a particular solution and then you are asked to determine whether that given solution is actually a solution to the differential equation, look within the differential equation. What's the derivatives within the differential equation? So in this differential equation, we have just uh, just order one derivative, meaning dy by dx, first order differential equation. So we can now replace y in this and also find the derivative of y using this solution that was given to us, replace it by dy by dx, and show that the left hand side is equal to the right hand side. If the left is equal to the right, it means this given solution is actually a solution to this differential equation. So let's apply the derivative method. So we have y equals 1 over 16 x raised to the fourth power. So what we're going to do, we're going to find the first derivative. So we have dy by dx is just equals, now the derivative is you bring this power down. Now this is 1 over 16. We drop this power 4. We rewrite x and subtract 1 from this power. So it's 4 minus 1. So this is now 4 going to this 16 goes there 4 times. So we have 1 over 4 x raised to the third power. So dy by dx is equal to 1 over 4 x raised to the third power. And then our y now is equal to this expression. So we're going to replace. Now we have dy by dx equals to x y raised to the power 1 over 2. So this expression now is just 1 over 4 x raised to the third power equals x. Now this y now is, what is this y? Y is 1 over 16 x raised to the power 4 or raised to the power half. So this guy now becomes 1 over 4 x to the third power equals, now this is x. So this 1 over 16 can be raised to the power 1 over 16 can be raised to the power half. And then also x to the fourth power, let's say x raised to the fourth power can be raised to the power 1 over 2. So now we can simplify. So this power means this is half the square root. So it's like saying the square root of 1 and the square root of 16. So this is x, the square root of 1 is 1, the square root of 16 is 4 times. So this 2 goes here 1 time, 2 goes into 4 2 times, so it's x raised to the power 2, 1 over 4, x to the third power, so it's 1 over 4, x raised to the third power equals, now 1 over 4, which is the coefficient, x times x squared is x to the third power. So because it had been verified that the left hand side is equal to the right hand side, using our derivative approach, we can conclude that this given solution is actually a solution to this differential equation. So let's use the integration approach or the integral approach. Let's say method 2. I call it the integral approach. Okay. So we have the problem now. For the integral approach, you are going to use the derivative portion because we can only integrate a derivative expression. We cannot integrate a function, right? We must integrate the derivative. If you have the integral of 2x dx, this 2x dx is called the integrand. And this integrand is a derivative. It's not just a function, it's a derivative, right? It's a function, but it's a derivative. Not just a kind of linear function or quadratic function or whatever function, but it's a derivative. So now we're going to use a derivative portion. We have dy by dx equals x times y raised to the power half. So what can we do? We can cross multiply dy times 1. So dy times 1 is dy. Dx times this, so it's x y raised to the power 1 over 2 dx. Now, the variable here that we must integrate is y. The variable here that we must integrate is x. So every other variable in this expression is considered a constant with the exception of x. So because y is here, we must get rid of y. We divide both sides by y raised to the power half. So this and this cancel. Now we're left with dy now y raised to the power 1 over 2 equals x dx. So we can integrate both sides. So we integrate this side and integrate this side. So to integrate y raised to the power half, remember now we said the integral of x raised to the power n dx is just equal to x raised to the power n plus 1 all over n plus 1 plus some arbitrary constant c, where n is not equals to minus 1. So n can be any other expression, but n should not be equals to minus 1. So if we look at this, this is not minus 1. So we can send this y in the numerator. So sending y in the numerator, you have y raised to the power minus 1 over 2 dy. And if we integrate x, remember the power is 1. The rule said we must add 1 to the power, x raised to the power 1 plus 1, and divide by the new power 1 plus 1. So we can integrate this one as well. Y raised to the power minus 1 over 2. We add 1. Divide by the new power minus 1 over 2 plus 1. And then equals to x squared over 2. So we can further simplify. So this minus 1 over 2, we can use a shortcut method. We just say 2 times 1 is 2, and that 2 is positive. You have minus 1 right there. So minus 1 plus 2 divided by 2. So minus 1 plus 2 is just positive 1. So that is y now raised to the power positive 1 over 2 all over negative 1. Now the same positive 1 over 2, because the same expression you have here is the same thing down here, equals x squared over 2. So what do we have? we have this 2 to come up here is 2 y raised to the power 1 over 2 equals 1 over, let's just maintain the same thing, x squared all over 2. So we want to solve for this, right? We want to solve for y, so we can divide this out by 2 and divide this out by 2. So this and this cancel. You have y to the power half is equal to x squared all over 4. Now, what was the equation that was given to us? What was the equation? What was it? What was the equation? We have, okay, so we have the y by the x equals x y to the power half. Then the function that was given to us now is just 1 over 16. So we should now be having, okay, so we just simplify that expression. So since we want to solve for y now, we can now say, let's, elementary this. Let's raise both to the power of 2. Raise this to the power of 2. So our y now would just be, remember you have plus c, plus c, plus c, plus c, plus c. Don't forget it. So our y now would just be x to the second power all over 4. Or let's say all over 4 times 4 is 16. Plus some arbitrary constancy. So you see? So it had been verified that this is actually a solution to this differential equation. Because if you use this solution and you differentiate, you will come back to the same thing, right? The derivative of c is just equal to 0. So even if it is y equals to x squared over 16, or it is y equal to x squared over 16 plus c, it makes no difference because the derivative of c is just equal to 0. So you can either use this method or you use this method, but I will prefer you using the derivative method. If they give you a function and you have one derivative, differentiate the function one time, insert the derivative and the y portion within the function, and you verify as to whether the left is equal to the right. If they give you a derivative with maybe second order derivative or third order derivative, differentiate the function 2 or 3 times, put each of those derivatives within the derivative that they gave you, and then you verify as to whether the left hand side is equal to the right hand side. If you wish to go this way, it's up to you. So this is the reason why I just exposed the 2 methods to you that you can be able to use. So thanks so much for watching. See you in our next video.